So here we have problem 14-101. It is a chain in a circular tube with no friction. Initially the chain is at rest and then the chain is going to slide out of the tube. We want to find the velocity when the chain is completely out of the tube. This problem is going to involve the conservation of energy. So here we have it written out. T1 plus V1 equals T2 plus V2. And then already drawn here we have a free body diagram of the initial state and the final state. Initially the chain is at rest. We have the center of gravity marked here on the diagram. We're going to have to know for the potential energy the initial height. From the back of our dynamics textbook, we know that the center of gravity for a quarter circle is 2r over pi from the center of the circle. So we have that written on our diagram, and then we're going to get the initial height from that value, since we know that the entire height of our semicircle is r. In our initial state, since it's at rest, our initial velocity is 0. In our final state, we're worried about finding that velocity. However, we know that the potential energy is going to be 0 because we have set our datum at the center of gravity in the final state. So for our conservation of energy equation, we know that T1 is going to equal 0 and that V2 is going to equal 0. So what we're going to have is mgh initial is going to equal 1/2 mv final squared. So first we want to find the mass of the chain. Now it is given that the mass of the chain is m sub 0 per unit length. So the mass is going to be equal to m sub 0 times the circumference of a circle, 2 pi r, divided by 4, which is going to equal pi over 2 times r times m sub 0. To find the initial height, we know that the total height of our quarter circle is r, so our initial height from the datum is going to be equal to r minus 2r over pi, which is going to equal pi minus 2 over pi times r, and that term will be easier to work with later. Now we need to plug this back in to our equation up here and simplify. So we have m, which is pi over 2 times r times m sub 0 times gravity times our initial height, which is pi minus 2 over pi times r, is going to be equal to 1/2 m times our final velocity squared. So then, simplifying from this, we get our final velocity is going to be equal to the square root of 2 over pi times pi minus 2 times gr. And with given numbers, we could solve for an actual velocity.